Welcome back to CS201 walkthroughs. Today we're talking about TC201s again, and I've made a full mess of my board, but I want to talk a little bit about assembling and about next config and about how a TC201 actually runs in our racket program, as opposed to this sort of high-level discussion of the various functions we have and how this example works. So I think first we'll start by talking about assembling. So if I have my example over here, which again I've made a mess of, maybe I'll kind of fix this here. Let's cross out. The process for assembling, I think I'll erase this stuff over here too. We shouldn't need that. Process for assembling is I'm going to go line by line, and I'm going to, I have two parts that I have to think about. I have the first 4 and the last 12 for each of my, the process of assembling is taking these instructions and turning them into RAM, right? And RAM is basically 16 0 or 1 digits in a row, right? 0 or 1, 0 or 1, 0 or 1, 0 or 1, 16 of those. So the first one, you notice this read over here. Some of them have this third, oh, this is really ugly. Some of them have this third part over here and some of them don't. That doesn't actually affect, in most cases, what I'm going to be putting over here in my RAM. So input 0, I ignore this read over here. I take the code for input, which may be different for you, but for me it's 6. So I'm going to put the binary number 6, which I think is a 4 and a 2. And then 0 is just going to be 12 zeros. Okay, for store I do the same thing. The first 4 is going to be the opcode for store, so that's 2. And then num store here is an address. So I'm going to need to look up this address in my symbol table. Okay, so we should talk about what a symbol table is. A symbol table takes all these third parts and associates them with the address they represent. So here, read is going to be the address 0. Option 1 is going to represent the address 9. 5 will be 12, 2 will be 13, etc. So that way, I make my symbol table first, and then when I want to look up something like num store, because store takes an address, right? And it wants the address of num store. I look up num store in my symbol table, I get 14. Now I can put, 0, ... and then at the end I'm going to have an 8 and a 6, so that's an 8, 4, 2, 0, right? So that's the importance of the symbol table. I can do the same thing. So here's add. Add is 3, so my first 4 digits are going to be a 3. And then my last 12 are going to be the address of 2 down here. So 2 is at location 13. Do I have to? It's an 8 and a 5, which is a 8 and a 4 and a 1. All right? So again, this part is not incorporated into this instruction. It's only relevant for my symbol table. These third parts over here are only relevant for the symbol table, so that I can look them up. Here I have jump option 1. The first 4 will be the opcode for jump, and the last 12 will be the address that I get when I look up option 1 in my symbol table, which will be 9. Okay, so this is how I assemble something. If you're watching this, I'll give you a little hint. Very often there's an assemble sort of problem on the midterm. So you're going to want to know how to make these 16-bit codes from something like this by hand. But you need to code it in your program. Or you need to code it in, homework 6. So it's good to know anyway. I guess then we can talk about how we do next config. So remember in my, yeah, sure. I think you have to do like first config too, right? Or init config. So to make the initial config, you basically assemble the instructions, take them and turn them into something that looks like this. Right? It'll end up being just as long as whatever this is. And then you attach that to a CPU. Remember, a CPU, I'm going to do some erasing to have more space. So a CPU has, as we said earlier, an ACC, a PC, RF, and A, E, B. I think in our first config, they'll be set like this. So for init config, we just have to assemble the lines of the program into RAM, and then make a CPU that has these. To get the next config, I think you first check the run flag. So if the run flag has been set to 0, then you need to halt, right? Run flag being set to 0 means you're done. So you just return the same config in next config. If the run flag is not 0, then we need to carry out the instruction, right? So we need to look at the PC. We have to go to wherever the PC, the program counter, says we are in the program. We have to execute whatever's there. So we have to look at our line. So I'll make this 3. We have to go to location 3. We have to read, or I'll change it to 2. We have to go to location 2. We have to read whatever opcode this represents. So here, this is a 3. 3 is do add. We have to add from this address, right? You've already written do add. So basically, all you're going to be doing in next config is taking the PC, going to that location, checking the opcode, and then performing that action. So in your do add, I think what you do is you read from an address and add that to the accumulator. You also need to change the PC. So after you do add, you need to make sure you're incrementing the PC by 1. So there you go. Right, in next config, first I'll write it out somewhere. I'll write it out up here. First I said check RF, then perform instruction at PC, and then increment her PC if necessary. So some of these instructions over here, you don't increment the PC for because it's already handled in some way. These skip instructions, they tell you what to do with the PC. When you run do skip, you'll increase the PC by 2 if some condition is met. So you should not increment the PC if your instruction is one of these skips. If your opcode at location program counter is a skip instruction. Same thing for jump. But for the rest of them, I think you probably do want to increment the program counter by 1. Okay, so I've talked about assembling, I've talked about next config. I think that's most of what you need to know for coding your simulator. If your simulator isn't working, highly recommend tracing it and try to figure out exactly which of these is not working. You'll basically, when you trace simulate or trace next config, I guess, you'll get a printout of here's your CPU and here's your RAM. And you can just look through. You can say, well, at what line am I messing up? Is my program counter increasing by 1 each time? Is my accumulator updating to what I want my accumulator to be updating to, right? And after you trace, again, if you don't know how to trace, require bracket trace somewhere at the top of your program, and then trace function name somewhere below your function definition. Then when you press run, it'll print out all the times that that function is called and what it's called on. You can just look through the CPU and the RAM of each configuration and figure out where it's messing up. This is a tricky pset, but again, if you trace, I think it's a lot easier. And if you understand kind of the process of assembling and what these functions are doing, which hopefully I've helped you a little bit with in these last couple of videos, then hopefully this pset won't be that bad. Thanks for watching. Come into office hours, email the CS201 help email or post on Piazza with any questions, and happy coding!